Okay, so today we'll be looking at module 25, which is network security data. And under this module, we're going to look at the core objectives for this course, which is to describe the types of data used in security monitoring. And then we'll look at the elements of an end device log file. And then we'll also look at elements of a network device log file. So we have to describe this element. Why we look at the element of an end device. So you're looking at security monitoring using data. You're looking at end device log file, and then you're also looking at network device log file. So let's quickly look at the types of security data. Under the security data, if you look at to your right, you can see a typical structure of a squirrel console showing test alert from SNOT IDS, intrusion detection system. I strongly believe that we've all installed Security Onion, and we know what the Security Onion does for us. It gives us the different layers, which as a cybersecurity analyst, you use that to always protect your critical data. So alert data actually consists of messages that are generated by intrusion prevention system, which is the IPS, or your intrusion detection system, in response to the traffic that violates a rule or matches the signature of known exploit. Recall, this is alert data for security monitoring. So the IDS, such as SNOT. So you can see here a typical example of your network detection system is your SNOT. It comes configured with rules for known exploit. And that will get when we're short, we have all this installed through our Security Onion. And then alerts are also generated by SNOT. And for SNOT, they are made readable and searchable by the Squirrel and the Squid application. So the Squirrel and the Squid application, which are part of your Security Onion suite of NSM tools. We're going to look at all these analyses with some of the labs, which some of you will have done, but we'll just walk through that and see how you run the sections to do the monitoring. So the sections and transaction data is a record of a conversation between two network endpoints. It includes your 5 tuple of source, destination, IP address, source and destination port. So you remember here you have to look at your source and destination IP address, and you also look at your source and destination port number and the IP code for the protocol in use. So these are the 5 tuples for the section and transaction of data. And we'll look at the section and data as section and transaction data still. So under these, when you look at the transaction data, it consists of the messages that are exchanged during network sections. So as you can see to your right hand side, this transaction can be viewed in packet capture transcripts, as you can see actually in a transcript. And the transaction that represents the request replies will be logged in an access log or in a server or by the NIDS like Zeek. So a typical example of the NIDS is the network intrusion detection system is a Zeek. And all this, the good news of all this is that they are there in your Security Onion. And there are questions that address all this for your practice. If you have done that, that's fine, but you haven't, like I said, we'll just walk through that so that it will help us understand what we are meant to do. So you always have to understand your intrusion prevention system and then your detection system. So a section might include the downloading of content from a web server as shown in the figure that you can see to your right here. So the full packet captures, the good thing is that a lot of us they use the Wireshark and we know how that works. So full packet captures are the most detailed network data that is generally collected. It contains the actual content of the conversation, such as text, of email messages, the HTML web pages, and your files that enter or leave your network. So you can extract content that can be recovered from full packet captures and analyze for malware or user behavior. The figure here shows the interface for the network analysis monitor component of Cisco Prime infrastructure system. This is completely Cisco based. As you can see, it's a Cisco proprietary tool which can display full packet captures. Just the same way you use the Wireshark, this also gives you almost the same outlook. But in this case, like we said, it will help to give you full packet captures. And the essence is to extract the content that can be removed from full packet captures and then analyze it for malware and all that. So that tells you that you can use this anytime to have a better way to diagnose packets that have full malware in them. So statistical data is about network traffic, which is created through the analysis of other forms of network data. Statistics can be used to characterize normal amount of variation in network traffic pattern. Remember, we're talking about statistical data, how that will help you to identify network conditions. And then similarly outside this, that's to give you some kind of broad understanding of the different analyses that happen within the network. So an example of this tool utilizing statistical analysis is Cisco Cognitive Threat Analytics. This is one of it that can help you to create that statistical data about network traffic. It is also able to find malicious activity that has bypassed security controls or entered the network through unmonitored channels, including renewable media, and is operating inside an organization environment. So the figure shows an architecture for the Cisco Cognitive Threat Analysis. So meaning that with this, it gives you more insight of some of the malware that actually bypass the network. So let's look at the end device logs, which are your hosts. Remember, we say your hosts are also end devices. So let's look at the host logs. So host-based intrusion detection system run on individual hosts. Remember, we talked about endpoint. We did talk extensively about these devices, end devices and all that, and the need to have inbuilt security in them. So there's also need to also look at their logs. So many host-based protections submit logs to a centralized log management system, which can be searched from a central location using the NSM tools. Microsoft Windows has host logs are visible locally through your event view keeps, and it has 4 types of logs. One, your application logs, and this log contains event logs for various applications, and then it also have what we call system logs. For the system logs, it includes your events regarding the operation of drivers, processes, and hardware. And it also have the setup logs. It has the security logs and the command line logs. And the event type, we have the error. So the table actually here will explain the meaning of the 5 Windows host log event types. And one is error. In this case of the error, it's an event that indicates a significant problem, such as loss of data or functionality. For example, if a service fails to load during startup, an error event is logged, which of course shows that there's a problem. And then the warning is an event that is not necessarily significant, but may indicate a possible future problem. So that's when you get a warning. And it's information when it describes a successful operation of an application. The drivers or services, for example, when a network driver loads successfully, you can say that's an information. And also when you have a success audit. And in this case, you have a success audit when a user successfully attempts to log to the system and it's a success audit event. So if a user is able to log in based on availability and able to access the resources or the repository, you can say this is a success audit. And it becomes a failure audit if a user tries to access the network drive and fails. The attempt is logged as a failure audit. So you can see the host logs, how it keeps all this, so that when you get into your host logs, you can be able to see all these events and then know the implication of them, because it is good you know how to capture all the information in the logs and have a better interpretation of what has really transpired. Probably you have a server online, and for that reason, this is you want to come in after some time to do monitoring. Remember, what you're doing here is more monitoring, and you now be able to interpret the issue. We talked about syslog before, but let's look at it from the end device logs perspective. Syslog include specification for messages format, the client server application structure, and network protocol. For already says is a client server protocol that we have discussed in the previous modules. Many different types of network devices can be configured to use syslog standard to log events to centralize syslog servers. So for syslog servers, like I said, primarily is to collect the different activities of what has transpired within the network in the server. And here, it also gives you the severity of the message. In other words, give you some kind of categorization of whatever has happened at a different point in time. Okay, and still on the syslog, let's look at the severity of the syslog. When it is 0, it means that it's an emergency and the system unusable. When it is 1, it's an alert action and must be taken immediately. And then when it is 2, it is critical. So you can see the order here. When it's 3, it has an error. When it's 4, it's warning. When it's 5, it is notice. And then 6, information now. Then you can see 7, debug. So this shows you the severity of what will have transpired within the network. Please just give me 1 minute, just a few seconds. Okay, so these are the severity values of the syslog. Recall what we're saying here is all these logs are captured in the server, meaning that it gives you the different activities that will have taken place and what the implication is all about. So meaning that when you see 0, it shows an emergency, that the system is unusable. That's what it means. So that means that if you want to carry out an investigation, probably for a server that is shut down or probably malfunction for 1 or 2 reasons, or probably have gone through an attack, with this you'll be able to do your interpretations and then provide detailed information. Remember, as a cybersecurity analyst, your job is to first analyze and then provide facts and then be able to mitigate against this attack. And that's the reason why we're looking at all the tools, available tools. Even most of the tools, actually, some of them are not mentioned here. That will also help for you to be able to analyze this packet at every point in time. So the priority value is calculated by multiplying the facility value, which you can see, by 8, and then adding it to the severity value as shown below. So the facility by 8 plus the severity value. The priority value is the first value in the packet and a curve between angle bracket. So if you look at what we have here, we've already been given the value, and then we'll be given the severity. So let's look at the server logs. Server logs are essential source of data for network security monitoring. Like your DNS proxy server logs which document all your DNS queries. I mean, your responses that occur on the network are usually important. And two important log files are your Apache web servers. So you can use for your web activities, access logs, and Microsoft Internet Information server access logs. So you can see for your Apache servers, like for your web, you can see the log, and then you can also see the log for your IS access log, which is Microsoft Internet Information server. Now, all these logs is to capture real-time activities within, like we say for the DNS, to capture all the DNS query responses and all that. And this is for you to be able to assess at every point in time, to be able to tell what has transpired in terms of activities. So the here we look at the security information and event management. Please, you need to note all this. In the course of doing the labs, we also need to refer to some of these tools, that's monitoring tools. The security information and event management technology is used in many organizations to provide real-time reporting and long-term analysis of security events, as shown in this figure. So you can see in the figure here, this is the security information event management. And what does it do? You can see the firewalls, it has the HIDs, it has server logs and 6log. So all these fall within your security information and event management. So the first thing that comes to your mind is that when you talk about the SIEM, all these must come in as part of the different activities that have to happen on the SIEM. You can see the net flow, telemetry, you can see full packet captures, and even as much as we just demonstrated that with the Cisco tool. So you can also see, so these are all under the security information and event management. So these actually combine the essential functions of SIEM and SIEM tools to provide a view of the enterprise network using the following functions. It has a log collection, and the log collection actually is event records, from your sources through the organization. And it also used for forensic information and help to address compliance with regards to reporting requirements. And then the same SIEM also used for normalization. In this case, you're looking at normalizing your data. So here you look at the maps, log messages from different systems into a common data model. If you recall databases, you show how the relationship between normalization of your data. So but in this case, it connects and analyzes related events, even if they are initially logged in different source formats. And then that's also what we call the correlation. In this case, the link logs and your event from disparate systems or applications, speeding detection of, and then reaction of security threats. And then you have the aggregation, the reporting, and the compliance. These are all under the SIEM, and they are the functions that make SIEM what it ought to be. And so if you look here, looking at your right-hand side, you can see the Splunk threat dashboard. This is actually a popular SIEM, which is made by Cisco partner. The figure actually shows the Splunk threat dashboard that is widely used in SOC, which is Security Operating Center, because of the lack of cybersecurity professionals. It helps to analyze the large volume of your security data. It's important that tools from the multiple vendors can integrate into a single platform. So invariably, this will do more of the analysis for you. And like rightly said here, because of the shortfall in cybersecurity professionals, so looking at how to have the platform. Please, you can mute your mic if you kindly mute your mic, please. So you can. This is for complete threat dashboard for monitoring malware or some security threat. So also have network logs. So you can see we're looking at different logs. For the network log, good enough, we know what the TCP dump is. It's a command line tool. It's a very popular packet analyzer, which also analyzes some of the past models using the Wireshark. It can display packet captures in real time or write packet captures to a file. It also captures detailed packet protocols and content data. So the Wireshark is actually a graphical user interface built on TCP dump functionality. I believe most of us have used the Wireshark, so they would use it for monitoring. And then the structure of TCP dump captures varies depending on the protocol captured and the field requested. NetFlow is a protocol that was developed by Cisco as a tool for network troubleshooting and section-based accounting. NetFlow provides an important set of service of IP applications, and which also include network planning, security, denial of service. It also provides information about network users, applications, peak usage times, traffic routing. So you can see the advantage of NetFlow. It also records information about the packet, flow, including metadata. Cisco developed NetFlow, and then allows it to be used as basis for ITF standards called the IPF fix. It also uses NetFlow also can be viewed with tools such as the NF dump. The NF dump provides a command line utility for viewing your data from the NF cavity capture, daemon, or collector. So NetFlow in general is that protocol that helps you at every point in time to be able to monitor different applications, the traffic, and then give you some kind of a demographic view of your network billing system and all that. So it's quite very, very useful. For those of us that have used it, we know how efficient and how reliable it is. So a basic NetFlow record in two different formats is shown in the figure. You can see the date, you can see the flow when it starts, you can see the duration, you can see the source IP, you can see the address, you can see the destination address port, you can see the flag, see the packet in byte. So this gives you a typical demonstration of what you have as within the packet itself. So the application visibility and control. The Cisco application visibility controls the AVC systems. This combines multiple technologies to recognize, analyze, and control over 1,000 applications. This includes your voice, video, it does your file sharing, gaming, peer-to-peer, and cloud-based application. The ABC uses Cisco next generation network-based application recognition version 2, also known as the next generation NBAR, to discover and classify the application in use in the network. So generally what we're saying with the ABC, which is application visibility and control, it just helps you to carry out your monitoring based on voice, video, email, file sharing, and all that. So we can see how all those provide a lot of inside activities in terms of what happens or transpires within the network. We also have, so you can see the demonstration of this. You can see the application recognition to identify application using L3 to L1 data. Like we said, over 1,000 applications, which include your cloud services. You can see the metrics, which includes your bandwidth, your response time, latency, and then the management and reporting, which has to do with report generation. That's based on performance, policy management, and then the control. Now, all that you have under the ABC. So still, for under your application visibility and control, you can see the port monitoring versus application monitoring. This is putting side by side activities within the port logs to show within the port, and that which is happening within the application itself. And this gives you the different, it gives you some kind of the performance of what happens. And all these are captured in a graphical form. They are all logs because they give you some kind of interpretation of the services that are wrong with the system. But in this case, you're looking at it from the port perspective and the application. So that tells you that once you have these tools, you're sure to have it to do this monitoring for you. And then content filter logs. Content filter logs, as it says, filtering your your diverse content. So these devices that provide content filtering, such as your Cisco email security appliance, which is the ESA, helps content filtering. And then the Cisco web security appliance, which is the WSC. They provide a wide range of functionalities for security monitoring. And then the figure shows the dashboard from Cisco using the Cisco web-based security appliance to demonstrate and give us an insight of the overview report, the detailed report, and the targeted search. All these tools, once you use them, they are sure to provide you more insight. And the good news is that we have labs that will carefully take our time to do. And that is why what we'll do as much as possible is to see that we take our time to do these labs. So I'm going to give us a window period of about 2 weeks from now to turn in all the labs. Reason because the labs is critical. It helps you to understand all what we're discussing here. And so we have the proxy logs from proxy servers, such those that are used for web DNS requests. Remember, when you talk about proxy logs, it all depends on which of the server applications you're looking at here. You can have proxy for your DNS. You can have proxy servers for email and all that. And the reason why you have this proxy server is just one, to enhance the speed of network, and also for monitoring, because within your proxy servers, you can access your logs, and then you can take, unlike when, for instance, if I have a DNS server set up within my organization, you can be rest assured that I can always check the logs directly. But if the DNS server is that probably on Google, it's not that can I be able to access that log? No, because I don't have the direct control over such. So, and that's why the proxy logs will go a long way to help. So we have a number of them. We have the Cisco umbrella, formerly Open DNS. It offers a hosted DNS services that extend the capability of DNS to include security and enhancement, all inclusive. So with this tool, you're sure that apart from the fact it does DNS for you, it also has this security capability. And then we have the next generation firewalls, services that extend network security beyond IP addresses and their 4 port numbers to the application layer and beyond. The next generation firewalls are advanced devices. They provided much more functionality than previous generation of network security devices. So one functionality is reporting dashboards with interactive features that will allow you to quick see the point-to-point, that's point and click reports on very specific information, the need for SIM or other event correlation. So this, what we're saying for the next generation file devices is that it gives you some kind of an extended security features beyond normal IP addresses and layer 4. That's beyond the transport layer, to give you more insight. And that's also one of the functionality is actually it has a reporting dashboard with interactive features that allow you to do the SIM, quick point and click report to give you better analysis of your data. And these are actually, remember the rule of firewalls, it's to monitor your inbound and outbound traffic. So common The next generation firewall event will include connection event, intrusion event, host or endpoint event, network discovery event, and net flow event, all encompassing within one firewall. So here's a packet tracer that will explore net flow implementation. So in this packet tracer activity, you will do the following: explore implementation of net flow. Like we said, net flow does a lot, so it is good we do these labs to be able to understand it better. So, like I said, more of the labs activities give us a better insight to what we need to do. So this is a network security data summary for all that we've looked at. So we look at different alert data types. We look at security onions, so based on snort, and also based on squeal, squid, and all these are and Kibana. Like I said, all these are there in the security onion for us to explore and see how we can use it to do look at alert data alert. You can look at the source, you can look at the count, the severity of this data traffic, all that will be displayed, which we're going to see in the course of the practical. And then we also talk about the section data, we talk about data about the section. We also look at full packet captures that contain the actual content of data conversation. We'll also look at the statistical data. We'll look at tools that help us to analyze this statistical data and all that. So that brings us to the end of this module, which is network security data. And like I said, a more practical demonstration will give us a better insight of this particular module, which we'll look at in the next class. So that's one reason why I said it would be nice we just finish this and then we'll have time to look at those labs. Okay, so here in module 26, you'll be looking at evaluating alert. How do you evaluate this alert? Remember, we have look at the data alerts. That means we have data that alerts that we can use to monitor traffic and tell when there's some issue within the network. But here the question is that let's look at how they are evaluated, because it's one thing that you use it for monitoring, it's another thing to evaluate it to give you the right result. So quickly, let's look at the objective. We need to identify the structure of alerts itself first, and then look at how alerts are classified to be able to evaluate them. So what are the sources of alerts? The first thing that comes to mind is security onion. What is security onion? Security onion is an open source suite of network security monitoring tools that run on Ubuntu Linux distribution. So that's the reason why you can see that it runs on Linux, hence the need to understand Linux. Security onion tools provide 3 core functions from cybersecurity analysts, such as your packet capture, your data types, network-based and host-based intrusion detection system, and alert analysis tools. So if I were some of us, what will come to your mind is that as you take a deep dive into the security onion, all these functions come to mind. It means that as you're doing your monitoring, you're looking at the core function, which includes packet capture. So how do you do that using security onion? Network-based and host-based intrusion detection system. How do you ascertain that using the security onion? And then the alert analysis tools, all that will, how do you use them? These are questions you need to ask, and so that once you start up the labs, it gives you a better idea of what you're searching out for. Security onion can be installed as a standalone installation or as a sensor and server platform. So remember, it also acts as a sensor. So we're going to see that too on the security onion and also as a server platform. Some companies with security onion are owned and maintained by corporations such as Cisco and the Riverbend Technologies, but are made available as open source. Note security onion is open source. Detection tools for collecting data. So what are the detection tools for collecting data? Security onion contains many components. It's an integrated environment which is designed to simplify the deployment of comprehensive NSM, that's for your monitoring. And then the system monitoring, you can see here the analysis. How do you carry the analysis? You look at Squill, Wireshark, and Kibana. So the very moment you're using these three, you're doing more of analysis. And when you're doing detection, how do you detect this whole threat? You need to look at it using the SNOP, the CAPME, the OSEC. These are under threat. And then data, the different data types. You look at how do you assess them through your host logs, alert logs, sys logs, metadata. All this we mentioned that content data, transaction data, and all that. They fall under data. So invariably, for short, you have analysis, detection, and data. And that is the much you'll be doing using the tools for. And the question now is that let's look at this component we've mentioned quickly under detection. Meaning that if you go straight to detection tools for collecting alert data, you look at component like CAPME. What does it do for you? It's actually for web application that allows viewing of your PCAP transcript rendered with the TCP flow or your zip tools. And also your SNOT. What does your SNOT do? Your SNOT is for network intrusion detection. It's an important source of alert data. And then you have your ZIG. Your ZIG is formerly known as BRO. This is a network intrusion detection system that is used more of a behavior-based approach to intrusion detection. So we need to have all the definition handy so that once we're carrying out this monitoring, we'll be able to do better interpretation. And for the OSEC is actually a host-based intrusion detection system that is integrated into security onion. And then we have the WASO, which is a full feature solution that provides a broad spectrum of end point protection. That is your end device protection mechanism, including your host log file analysis, your file integrity monitoring, your vulnerability detection, configuration assessment, and incident response. And then we have the Secreta. This is also your network intrusion detection system. Now, in this case, this uses signature-based approach, so it can be used for online intrusion prevention because it has to check the signature to be sure. So these are the components we have under the detection. Remember, this is detection tools for collecting alert data. And for the analysis, we mentioned that earlier, the Squill, the Kibana, the Wireshark. So for the Squill, it's for investigating security alerts from a wide variety of sources. The Squill actually serve as a starting point in the investigation security alert, which you can see from the architecture. So many data sources are available by pivoting directly from Squill to other tools. So you can actually, it becomes the first one that you need to use. And it's available first by pivoting directly from Squill. And the Kibana is more of like having a dashboard, very interactive, to elastic data. It allows querying of your NSM data. It provides flexibility visualization of your data type. It is possible to pivot from Squill directly into Kibana. What it means that by pivoting, we say you can actually switch from this to Kibana. Mind you, all of them, they are all analysis tools. But Kibana is quite very, it's good for visualization. In other words, if you really want to do better interpretation for management, maybe for top management, it gives you a very nice dashboard. So we also look at that. And then we have the Wireshark. For the Wireshark, it's already encapsulated in the security onion, which Most of us have started using that already. And then the ZIC is actually network traffic analyzer that serves as a security monitor. It inspects all traffic on the network segment and enables the in-depth analysis of that data. Okay, and so for alert generation, security alerts actually are notification messages that are generated. And the reason why they are generated is they come in many forms depending on the source. So sometimes they come, some of these alerts will be positive, could be negative, could be false, negative, positive, and all that. It all depends. So, but in this case, under the security onion, Square will provide a console that integrates alert from multiple sources into a time-stamped queue for us to be able to analyze. A cybersecurity analyst walks through the security queue, investigating, classifying, and escalating or retiring alerts. All this, the beauty of it is that we all have them embedded in the lab. So alert will generally include 5 tools. You call the 5 tools you mentioned, which has to do your source IP. So the alert will either come from all the sources, which we already know. So it's either from your source IP, from your source port, your destination IP, and your destination port, which is on layer 4. So for the alert generation, as you can see on the right-hand side, the figure shows the Squirrel application window. When we are doing this, you see all this. If you're running the labs, if you're doing it on your own, you see all that displayed. It gives you the status of the event. It gives you the count, the number of times the event has actually been detected for the same source and destination IP addresses. The good thing about it is that it will show all those counts, and then also with the sensor, which is the agent, it will reporting the event. The label sensor and their identifying numbers can be found. This can be found. And that's sorry. Okay. Okay. So I said this is for the status, and then for the count, and then for the sensor. And it's what does the sensor do for you? Like we said, it's actually identifying the numbers that can be found in the agent status tab, which appears before the event window. And all that are displayed here on the right hand side, as you can see under the squeal. And then the alert ID. The alert ID is there. The 2 part numbers represent the sensor that has reported the problem, and then the event number for the sensor. And so it also gives you the date and time when this event has happened. It also gives you event message. And then if you look also to this end where you have the event message, the event message gives you an in-depth of what happened. If it has some suspicious information in terms of threat, it will also report that on that event message. So it's identifying text event is configured in the rule that triggered the alert. So the associated rule can be viewed in the right-hand pane, just above your packet to display the rule. The small rule check must be selected. So you have to select that from the squeal on your right-hand side. But this is better off when you're doing the labs. Then rules and alerts. Alerts can come from a number of sources. You can have alert from the network intrusion detection system, which has to do with your SNOT, your ZIC, and your Stricata. And then your HIDS, which is your host, which is OSEC and WASO. And then we have asset management and monitoring. Which has to do with your passive asset detection system. And then you have your HTTP, DNS, TCP transactions. These are recorded by ZIC and PCAPs. And like I said, all that used, syslog messages, multiple sources, and all that. This actually happen under the rules and alert. So please, I want us to have all this information handy So in the course of the lab, it will be quite easy for us to relate to them. So SNOT rules consist of two sections as shown in the figure, the rule header and the rule options. So the rule location is sometimes added by square. So it has the rule header and what it has the location also that is added. So if you look down here, you can see the alert IP any giving you some insight of, and then you can see the message telling you the attack response ID check return route, and then you can see telling you the service security, and then giving you the port that this is happening, and then downloaded to rules line. Now all give you the port number and all that. So usually the slot rule structure will first of all show you the rule header, that's the header here, and then it will also give you the rule option and then the location where this has actually happened. It's in some cases, but that you can get under the scroll. So there's a lab which we'll do, which we already have, I think lab 22 also. That lab gives more insight to all that we have here. So to help, if you really want to do that, you can do. So for the rule header, is your alert IP any, and it contains the action to be taken, and the source and destination addresses and port, and the direction of the traffic flow. And then you have the rule options. The rule options now gives you the message, the GPL attack response ID, and then you have the rule location. For the location, you can see the NF server, that's where it has happened, which give you a description of the server. So you can see the rule option, which is your GPL attack. So all this will come as questions to enable you as a security analyst to locate them wherever they are. And then components like your alert, which is the action to be taken the action taken, which is to issue an alert. Other actions are log and pass, and you have the IP as protocol. You have any recall this any a specified source. It has to do with your layer 4 port, and then the direction of flow is from the source to the destination. All these are components which you should know, and then the explanation tied to them. So in case you're asked to search for either of this, you'll be able to figure them out from this report. So we're saying anytime you see the alert, what it means in this case is the action that is to be taken to issue an alert. And then when you see the IP signifies a protocol, and when it's showing you any, at that point in time, you're knowing that it's actually want to specify the source of the IP, and then the port as layer 4, and then for any it has to specify the destination is any IP address and any layer 4. So please, we need to note this before going to the labs. And in the rule options, this has to do with the structure of the options section of the rule variable. The SNOT rule messages may include the source of the rule, which there are 3 common sources for SNOT rules. One is the GPL that we saw also, is the oldest SNOT rules. They were actually created by SourceFire and distributed under the GPL version 2. The GPL rule set is not Cisco Tower certified. It is the rule set can be downloaded from the SNOT website and distributed in the security. And then we have the ET, which is SNOT rules, and then we have the PRT. These rules are immediately available to subscribers and are released to register users 30 days after they were created. These are actually rules And all these rules actually are tied to the text message, the type, alert, and all that we have discussed. So all that we use them or we demonstrate in the course of the lab, and then the component. For your component is the message. How does the message comes? It comes in a text to describe your alert. And then when you see the content, the content will actually refer, to content of the packet. And then your reference, it's also showing the figure, is often a link to the URL. So in case you ask the reference, you're looking at links to the URL. And then the class type, this has to do with the category for the attack. And this has to do with, which includes, it has to have one of 4 priority value. In other words, there'll be priority values given attached to it in numbers. And then you have the source ID, which is a unique numeric identifier for the rule. And then the rev, which has to do with the revision of the rule that is represented by the source ID. So all these are components that will be captured in the course of, so you can see for message, you can see what the message is and the GPL attack response. And then if you ask for the content, this is the content here, which is UID. You can see the content is 120, and then gives the root value. And then the reference is also captured also too. Now, all this that we're talking about, they are all stated within this content. And like I said, it's just for you to take your time, be able to interpret them at every point in time. And these are the questions that will come. And then in the lab, you will complete the following objectives. So let's see, look at it. 1, you perform the monitoring of IDs and event. You configure your own customized firewall to stop our internal host from contacting a malware hosting server. Because recall, when you have a malware server that probably for 1 or 2 reasons compromise your network, it means that your host can be relating with this malware server all on the ground of either one of the systems have been taken hold of. Remember, this is happening within the network. So craft a malicious packet and launch it against an internal target. The good thing about this practical is that there are online access to some of the servers for better interpretation. You also need to have efficient internet system to be able to carry out this. So create a customized IDS rule to detect the customized attack and issue an alert based on this. So there's a lot you need to do, which will help. So overview of alert evaluation. So let's look at the overview. Remember, we talked about the squid, and we said we have a Kibania, we have a Zig, we have a Wireshark, and all these are actually used for giving some level of analysis that's analyzing using either of these strategies for visualization. Remember, we mentioned that to give you a better interpretation of what you have. So it will give you a dashboard to give you a better analysis. And like I was saying, alerts can be classified in different forms. They come as true positive. In this case, it's true positive when the alert has been verified to be an actual security incident. But it's false positive when it does not indicate an actual security incident. An alternative situation is that an alert was not generated. So the absence of an alert can be classified as what? True negative. That's when no security incident has occurred. But it can be false negative when an undetected incident has occurred. So that means, like we said, you can have serial binders with some threat already that passed through the network. That means that can come under the false negative alert. So you need to know that means it actually entered the network undetected, and that could be very devastating. So you have to note down these different alerts that are issued. So for positive alert, it exists. It is true. That means incident has occurred. And when it's false, that means no incident has occurred. So that means you can have true positive alert. You can have false positive alert. You can also have true negative alert. in that case, no incident has occurred. And you can also have false negative alert. That means incident and already occurred. Okay, so these are different ways. Like I said, when we do these labs, we'll be able to have more insight to what is expected. So I'll take my time in the next class so that we can do justice to the labs, take it one step at a time. And you see that you can apply most of these theories. So if we look at that, then that will take us to the next module, which is module 27. Okay. In the module 27, we were looking at okay, we're looking at working with network security data. So let's look at how you work with network security data. So working with network security data. So quickly we look at the objective. So the objective is to be able to explain how data is prepared for use in network security monitoring, and then use security onion tools to investigate network security events, and then describe network monitoring tools that enhance workflow management. So a common data platform. So here is a common data platform. Security onions include Elastic Stack that consists of Elastic Search and contains Logstash and Kibana. So the core component of ELK, which is electric charge, the question is what is Elasticsearch? It's actually an open core platform for searching and analyzing organization data in real time. So it's open core, gives you the ability. So you can see we have Kibana, we have Elasticsearch, we have Logstash, and then we have the bit on the right hand side. They are all common data platforms. For the Logstash, it actually enables collection and normalization of network data into data indexes and can be efficiently searched by Elasticsearch. And then the Kibana, we've talked about that, which says it provides visualization, graphical display on dashboard. And then for the bit, it's a series of software plugins. And what do they do? That send different types of data to Elasticsearch data stores, which you say is an open core platform. So data reduction. So to reduce data, it's essential to identify the network data that should be gathered and stored, to reduce the burden on system. So by limiting the volume of data, tools like Elasticsearch will be far more useful as compared to others. So for data normalization, like we said, it's the process of combining your data from a number of sources into a common format. So a common schema will specify the names and formats for the required data field. For example, if you have an IPv6 addresses, your MAC addresses, date and time can be represented in verifying your format. That means when you have these combinations, it gives you a better way to identify your format. So you can see here the IPv6 address. I want to believe all of us will understand how IPv6 address have been displayed, and then the MAC address. And the data format is Monday to the 4th, this 739 to give you the format for that particular period. So this is for data normalization, and it's also required to simplify searching for correlated event. In one of the labs too, you'll be asked to search out this, given a particular date when an event occurred, and then be able to find out, what has transpired or not, and then get some one or two information out of that whole scenario. So like I said, the labs will go a long way to give us a better insight. And then data archiving, retaining network security monitoring data indefinitely is not feasible due to storage and access issues. So you should note that it's not easy due to visibility to storage and access. So the retention period for certain types of network security information may be specified by compliance framework. So the SQL alert data is retained for just 30 days by default, and this value is set in the security onion.config file. So this can only happen under 30 days, meaning that you have to, from the time that has occurred, or you have enabled your skill, you should also have at the back of your mind that after 30 days, that will not be available. So security onion data can always be archived to external storage by data archive system, depending on the needs and capabilities of the organization. So there are lab is to convert data into universal format. So in this lab, you complete the following: use command line tools to manually normalize your log entries, and then 2 is the timestamp field must be normalized, and then 3, the IP business field requires knowledge. So investigating network data. So investigating network data has to do with working in SQL. Like we said, SQL will help us to look at the source, the count, number of times event has occur. It will also help us look at the message type and all that. So I think during the labs, we'll be able to demonstrate most of these queries using all the investigations and the API. So all you're seeing here, like for the Kibana, you can see the Kibana to your right, left-hand side. Like I said, is for visualization. So the labs will go a long way to help. So I can go along doing the lab. When we also come to the class, we'll do that together to see how you can use that for graphics and for visualization. And then interpret HTTP DNS data to isolate threat actor, and complete the following objective: investigate SQL injection, that's a database, and DNS exfiltration exploit using security onion tools. Play the video and then recall the tuple, 5 tuple, which we've talked about. And then investigate malware exploit, investigating attack on Windows host. And then here, let's look quickly talk about enhancing the work of the cybersecurity analyst. So the dashboard and the future, like we said, using the Kibana will enhance the work of a cybersecurity analyst. It makes your job easier for you. So you will decide which of these evaluating tools you wish to use to carry out your analysis. And then also for workflow management. In this case, it will also help the sequence of processes and procedure through which work tasks are completed. So it will help you manage the security operating center workflows. It will enhance the efficiency of the cybersecurity team. It will increase the accountability of the staff. It will ensure that all potential alerts are treated properly. So and I would advise that you have all these installed. You can have a server for this and start doing the monitoring. But be careful, you don't most of this before you use it on your network. So some level of you have to use some discretion to do that. It's not just connecting to the network. So that's the reason why if you go through a study like this, before you apply some of these things, you have experimented them to be sure that you have a very clear understanding of what it is working with these tools. But quite interesting because it will give you a better illustration. So let's look at the last module, which is digital forensics and incident analysis response. Okay. So when I'm done, I can give room for question. There's question, so we can get that. So I have all of them all open. So let's look at mode 28. Mode 28 has to do with digital forensics and incident analysis and response. And quickly, let's look at the objective. So the objective is to explain the role of digital forensic processes, identify the steps in cyber kill chain, and then classify an intrusion event using the diamond model. Then we look at how to apply the NIST 806.61 R2 incident handling procedures to a given scenarios. So evidence handling and attacking attribution. So here we look at the digital forensics. You need to know what it is. Is the recovery and investigation of information found on digital devices as it relates to criminal activities. So once you're able to carry out this discovery, you said you will apply digital forensic. So indicators of compromise are the evidence that a cybersecurity incident has occurred. For example, under the US HIPAA regulations or health ground, if data breach has occurred involving patient information, then notification of the breach must be made to the affected individual. So, is a rule. It's like we said, is the incident response. So once your health record has been breached, there's a need to get in touch with you immediately. So digital forensic, I hope this is also practiced in our countries as well. But I know Africa will have a lot of setback when it comes to this. Even when there's compromise in some African countries, I know it will be an issue to get back to the patient in some cases. So at times, cybersecurity analysts may find themselves in direct contact with digital forensic evidence that details the conduct of members of the organization. So analysts must know the requirements regarding the preservation and handling of such evidences. So the digital forensic processes under the NIST will describe the four phases of the digital evidence of forensic processes, which is one is collection, two examination, analysis, and reporting. So the collection is to first identify information of potential sources of forensic data and acquisition, handling, and storage of the data. That's the first thing. Two is examination. That's assessing and extracting relevant information from the collected data. And then three is analysis. Here is drawing conclusions from the data that is collected, correlation of data from multiple sources. And four, like we said, reporting. This has to do with preparing and representing information that resulted from the analysis tools. So these are the procedure for your digital data as a digital forensic process. So at every point in time, you must do the collection, you must examine, you must analysis, and then when you analyze, you must do reporting. So types of evidence. So in legal proceedings, evidence is broadly classified as direct evidence. And when it's direct evidence, it's indisputable in the position of the accused, or is the eyewitness or evidence from someone who directly observed criminal behavior, who is so sure and very precise that this actually occurred. And then the indirect evidence is this evidence establish a hypothesis based on hypothesis in combination with other facts, other lay down rules, lay down facts to see. It's also known as what we call circumstantial evidence. And then the best evidence, this evidence could be storage device used by an accused or archives of files that can be proven to be unaltered. These are best evidence, probably like a log, that keeps all the detailed information of what the accused have done. The time he logged in, the time he or she initiated a particular action, and you have such information, so we call it best. And then corroborating evidence is this evidence actually will support an assertion that is developed from best evidence. So this is the evidence and collection order as provided. The IETF Reserve 327 describe an order for the collection of data forensic based on the volatility of the data, how volatile the data is, and the data stored in RAM is the most volatile and will be lost when the device is turned off, which you agree with me. Most of those information that are not actually stored in the main storage or archived in the main storage. So the collection of data evidence should begin with the most volatile evidence quickly and proceed to the least volatile. Remember, because that can be lost easily. And details of the system which the evidence was collected, including who has access to those systems, and at what level of permission should it be recorded. That's the evidence collection order. So you start from the highly volatile storage to the one that you show have a permanent storage. So chain of custody. So chain of custody involves the collection, the handling, and secure storage of evidence. Detailed records should be kept in the following: who discovered and collected the evidence, as the first, and then two, all details regarding the handling of evidence, including time, places, and personnel that are actually involved should be captured. Who has the primary responsibility for the evidence, and when responsibility was assigned, and when custody actually changed. These are what we call the chain custody. And who has physical access to the evidence while it was stored. Access should be restricted to only the most essential personnel. The reason is because if you don't restrict it to the essential personnel, then there's a high level of possibility that they could be compromised. And that's the reason why you need to look at the chain of custody, who is able to handle what and what, and then who is responsible at every point in time. All that is just to, and then at what point is that responsibility changed? All that are needed. These are part of the investigation processes to be able to have a good case. And because if you don't follow this procedure, you might not have a good case. The reason is because as a cybersecurity analyst, you must also understand some of these legal procedures. If you don't, then you might lost it in the court of law. So data integrity and preservation. The timestamping of files should be preserved. Hence, the original evidence should be copied. An analysis should only be conducted on copies of the original. So the timestamps may be part of the evidence. Opening files from the original media should be avoided. So you also have to look at archive and protect the original disks to keep it in its original untampered with condition. So that's why when all this information you're going to make sure all these procedures are followed for preservation and the integrity of these the information. So users should not disconnect, unplug, or turn off infected machines unless explicitly told to do so by security personnel. And who are security personnel? By the management security personnel that's within the organization itself. Because in the course of trying to carry out investigation, you want to be sure that the integrity is still ascertained and then it's still highly preserved. Then let's look at attack attribution. Threat attribution refers to the act of determining the individual, the organization, or nation responsible for a successful intrusion or attack incident. So in this case, identifying responsibility threat actors should occur, through the principled and systematic investigation of the evidence. And then also note under still attack attribution and the evidence-based investigation, the incident response team correlates, tactics, techniques, and procedures that were used in the incident with other known exploits. All that has to be put into consideration. So some aspect of a threat that can aid in attribution are the location of originating host or the domain, features of the code used in the malware, and the tools and other techniques. So these are actually attributes, different attributes that should be looked into. And then for the internal threat, you also need to look at the asset. The management plays a major role here, uncovering the devices from which an attack was launched and can lead directly to the word threat actor. So in this case of an internal threat, asset management plays that role to make sure it is properly protected. IP addresses like MAC addresses and DHCP logs can also help track the addresses used in the attack back to a specific device. So these are attributes for attack, which a cybersecurity analyst need at every point in time to be able to put all those knowledge base together in the course of tracing the cause of some of these attacks. So we also have some condition here, which is the MIT attack, ATT, and the CK framework. So for the MIT adversary tactics, techniques, and common knowledge, which is the ATT and CK framework, enables the ability to detect the attackers and tactics, the techniques of the attacker, and procedures as part of threat defense and attack attribution. So here, the tactics consist of the technical goals that an attacker must accomplish to execute an attack. There are technical goals that it has to follow, and techniques are the means by which the tactics are complied. So meaning that we're saying that this attacker must go through some techniques, maneuver his way through some procedure. So the procedure are the specific action, and we need to look at what those procedure will be. That will take us to what we call the cyber kill chain. So the step of the cyber kill chain was developed by Lockheed Martin to identify and prevent cyber intrusion. So when responding to a security incident, the objective is to detect and stop the attack, which is sure at the earliest in the kill chain progression to avoid further damage. So please you note this, that the main objective is to detect and stop the attack before it actually spread, which is the key thing. That's the reason why most organizations or countries that have very strong security architecture they make sure that they go after the criminals even before the criminals, take out action. Because the damage, you can't sometimes quantify the damage. So if the attacker is stopped at any stage, the kill chain is broken and the defender successfully thwarted the threat actor's intrusion. And that means that it shouldn't be allowed to go past the stages so that you can stop it immediately. So the threat actors to the party instigating the attack. However, the Lockheed Martins uses the term adversary in cyber kill chain. Therefore, the term is adversary and threat actor are used interchangeably in this topic. So in case you hear adversary, we're also referring to the threat actor. So if you look at what we have here, you can see the chain, the cyber kill chain. You can see one, which is the recognizance, search target information. Two is weaponization. And here is pairing remote malware with backdoor to create a payload. And two is delivery, weapon to victim through email or other means. So we're saying that, of course, the adversary will have to go through some techniques, through some steps, ways to be able to launch his attack. And exploitation, this execute body on the vulnerable system by triggering the code. And then once it gets to 5, what happens is that installation of backdoor on target to install malware will start. And then once it is 6, the command and control outside the server command channel is created, to manipulate the target. And then at the 7th stage, action on objective, the attacker will use hands-on keyboard access to achieve the objective of the attack. So at every point in time, the threat actors or the adversary will always go through these steps of the cyber kill chain to be able to carry out its final action. So like we said, recognizance is research target information. That is, so at that point of recognizance, you're saying that that's where all the research is done. And then the weaponization is when it's pairing with malware or using some backdoor. And then the delivery is when it's already delivering the weapon to the victim, and that delivery could be through email or through other means or channels, as the case may be. But remember, the delivery will always happen in the course of using either using IP spoofing or MAC address, whatever, cloning to be able to, get into. So whichever means that happens is delivered, and exploitation is when using as a code to leverage on the vulnerability. Then installation is when this is already having access to the backdoor to install its malware. Like we said, the command is when the outside server command chance is created, and then like we rightly said also, the action on the objective is when the guy has actually launched. So in the same way, you as a cybersecurity analyst try to have your own procedural steps, to carry out your analysis using skill, using the detection tools, the analysis tools, and all that. This is the same way that the attacker will always, or the adversary will always use his own procedure. So that was explained, looking at their process. And then let's look at the diamond model of intrusion analysis. In the diamond model overview, this intrusion analysis represents a security incident or event. The 4 core features of an intrusion event under the diamond model is adversary, which is a party responsible for the intrusion. We've explained that already. Capability, which is a tool or techniques used by the adversary. And then the infrastructure is a network, and the victim is target of the attack. Remember, the victim could be your system. Having that for content. So not that it's attacking you directly, looking at the procedure in which it has to use and finally attack. So still on the diamond model of intrusion analysis, looking at the pivoting across the diamond model. So it's an ideal for illustrating how the adversary pivots from one event to the next. For example, an employee reports that his computer is acting abnormally. So a host scan by the security technician, as a security analyst, indicates that the computer is affected with malware. So what happened? An analysis of the malware reveals that the malware contains a list of CNC domain names that resolve to a list of IP addresses. And then these IP addresses are used to identify the adversary and investigate logs to determine, remember with the IP address, we need to tell the source, or the destination, and if other victims in the organization using the CNC channel. So events are threaded together in the chain in which each event must be completed before the next event will occur. We've looked at how the adversary guys carry out all this. So the example illustrates the end-to-end process of the adversary as it traverses cyber kill chain. And the cyber kill chain has really helped us to know how to go through all the various stages before finally be able to carry the final act of, taking off the system, or the exploit is being carried out. So adversary conducts a web search for victim company gadgets by receiving part of the result domain name gadget.com, for instance. So the adversary will search the network, administratorgadgets.com, and discover forum posting from the users claiming to be network administrators of gadget.com. Then the adversary will send phishing emails, which is a delivery, with a Trojan horse attached so that you might not be able to tell. And then once that is done, one network administrator opens the malicious attachment which executes the enclosure exploit. And then when the NA host register with the CNC controller by sending an HTTP post message and then receiving an HTTP response in return, it is revealed from reverse engineering that the malware has additional backup IP addresses. Okay, and then through the HTTP response message sent to any host, the malware begins to act as a proxy for new TCP section, because at this point in time, this is a reverse order. Once the whole attack, everything has been launched, it has gotten the clear information of what the end device is, which is server, for instance. Then automatically, the last stage will now happen where the malware begins to act as a proxy. The proxy is that every other person will be looking up to that end node. And so you can see it's the same procedure here, but here is in the reverse order, because once I'm able to carry out an action as a threat actor, all the system have been done the installation and now ready in the system. The next thing is you monitor the traffic already through the CNC HTTP response message back to the source. And the next thing is to act as proxy. So every other person now will see you as a server, and when you begin to monitor until you have some sensitive information coming out from the other end devices. So let's look at the incident response. Establishing an incident response capability. So incident response aims to limit the impact of the attack, assess the damage caused, and implement recovery procedure. So incident response involves the method, policies, and procedure that are used by organizations to respond to cyber attacks. So they use this procedure to respond to cyber attack. So note, although this chapter summarizes the content in the NIST 8006102 standard, you should be familiar with the entire publication as it covers 4 major exam topics. Understanding Cisco cybersecurity fundamentals. So we have to note this. But basically, you should also note that under the incident is to look at the damage and to look at how to respond through this by following the procedure, the policies procedure that are used by a organization to respond to a cyber attack. So we'll look at those policies also. So the below are summarizing the policy plan and procedure element in an incident response. So when this attack happens, what are the policy elements? The statement of management commitment, the purpose and objective of the policy should look into the scope of the policy, definition of computer security incidents and related terms, the organization structure, how it's being structured, the rules, the responsibilities, and the levels of authority in that organization. They all form the policy. And the prioritization of severity rating of incident, how it's being rated. The organization can fine-tune these priorities, performance measures, reporting and contact forms. How is the reporting done? So there are procedures for reporting. So you need to understand every organization have their own procedures for reporting. And all that has to be looked into under incident response. And plan element, the mission, the strategies and goals. This has to do with senior management approval. Before I can commence anything, organization approach to incident response, how the incident response team will communicate with the rest of the organization and with other organizations. You also have to look under the plan elements to the metrics for measuring the incident response capacity, and how the program will fit into our organizations. And then the procedure element, this has to do with the technical processes, using the techniques, and filling out forms, and then following checklists. So all these 3 must be put together for you to actually do justice to incident response. So incident response, what are the stakeholders? The management, the information assurance, the IT support, your legal department. They are all stakeholders. They belong to this domain called the incident response. The human resource, the business continuity partners, fiscal security, and facilities management. This is a lot of things that we need to look into. For some organizations, stakeholders are more than what has been stated here. So the incident response stakeholders, so here we're looking at the cybersecurity maturity model specification, which classifies organizations by level. So for most domains, there are 5 levels, however, for incident response. And let's look at those 5 levels for incident response. One is, so there are only 4 so far. Even though there are 5, there are 4 available. The level 2 is to establish, is to establish the incident response plan that follows the NIST process. Level 3 is to document and report incidents to stakeholders identified in the incident response. So we've actually looked at the stakeholders. So it's to document and report the incident. And then level 4 is to use knowledge of attacker. TTP to refine the incident response planning and the execution. And then the 5 is to utilize accepted and systematic computer forensic data gathering techniques. So these are actually 4 incident response maturity model certification processes. So the essence of all this is to be able to first establish, document, then use the knowledge of the attacker, and then utilize accepted and systematic computer forensic data gathering techniques. So you need to have all this together. Remember, all these are more or less like an incident that's happened. How do I respond? So we're looking at incident that occurred and the response approach to it. So according to the NIST incident response life cycle, they define 4 steps in the incident response processes, which is 1, preparation, 2 has to do with detection analysis, and 3 containment, eradication, and recovery, and then 4 post-incident activities. So if you look at it, this forms the life cycle. And for the preparation, what are you doing here? The members of the CSRT, what would they do here? They would train in how to respond to an incident. That means they have to be trained, and then to detection and analysis. I think we explained this on the. But in this case, we're looking at the incident that has happened already. So this has to do. This is to quickly what identifies, analyze, and validate an incident under the detection. So under detection, they must what? Quickly identify. Because if you don't quickly identify, sometimes by the time you're taking action, it may be too late. And then containment, eradication, and recovery. Here you are implementing a procedure to contain the threat, as to contain that threat. It's as a containment. And then how to eradicate it, and then the recovery. And you can use backups to restore data and software. In that case, either some maybe damage or some kind of distortion or code abuse or whatever. And it's malfunction, you can do a recovery and still follow the incident. So most incident activities, like we said here, this has to do with the sys document, how the incident was handled, recommend changes for future response, and specify how to avoid the reoccurrence. And then preparation, incident preparation. So if it has happened, let's look at the preparation. So the preparation phase is when the SIS is created and trained, the cybersecurity analysis trained. The tools the tools and assets that will be needed by the team to investigate incidents are required and deployed. So example of actions in the preparation for phase as follows. 1, facilities to host the response team and the SOC are created. And 2, the risk assessment are used to implement controls that will limit the number of incidents, so you don't have more incidents happening. And then user security awareness training materials are also developed to also help to add some knowledge or create more knowledge for the users, and the necessary hardware and software for incident analysis and mitigation is acquired. So this is for the preparation for an incident response. And then detection analysis. For detection analysis, the types of incident will require different responses, definitely. So for attack vectors, web, your email, loss of theft, impersonation, attrition, and media. Then for the detection, automated detection, antivirus software, your IDS, your manual detection, your user report comes under the use for detection. And then analysis, you can use the network and system profiling to determine the validity of the security incident that occurred. And scoping, your scoping will provide information on the containment of the incident that happened and deep analysis of the effects of the incident that have already occurred. And then the incident notification, this will notify appropriate stakeholders. We already know who the stakeholders are in the organizations. And all the stakeholders will have to notified an outside parties. So once the incident is analyzed and then we prioritize. Remember, all this have to happen very fast and quickly. So let's look at containment, eradication, and recovery. Under this case, containment, like we said, the strategy. So if this is how do you contain this? For every type of incident, a containment strategy should be created quickly and enforced depending on some condition. Then the evidence, so during an incident, evidence must be gathered. You have to do evidence gathering to resolve it. It is required for subsequent investigation by authorities. So those evidences will have to be kept. And as I see some of these, if you put this in the real world, there's some of these, some investigation will take a long time, before they are tracked. But as much as possible, as a cybersecurity analyst, you have to swift in coming to situation. But in this case, we're looking at incident response, means that it has happened, and then you're trying to follow lay down rules and policies, procedures, plan of action to see how best we can, investigate that issue. So attacker identify attackers will minimize the impact on critical business assets and services. So eradicating recovery and remediation. So to eradicate, identify all hosts that need remediation. To recover hosts, use clean and recent backups, or rebuild them with installation media. So let's look at the post-incident activities. After the incident call, it's important to periodically meet with all the parties involved to discuss the event that took place and the action of all the individuals while handling the incident. So lessons based on hardening. Hardening is to more like, help to strengthening, or in some cases, the hardware infrastructure. So the organization should hold a lesson learned meeting to review the effectiveness of the incident handling process based on what have occurred. You need to strengthen that, identify necessary hardening needed for existing security controls and practices. So in case based on like evidence-based event, this has happened, how do we strengthen that? So the below table will summarize the incident and data collection and retention. So here you see the incident data collection. One, the collected data after the lessons learned meeting can be used to what? So if the stakeholders have met based on the incident that occurred, the meeting that is being, the outcome should be used to what? Determine the incident cost for budgeting, have to determine the effectiveness of the assist. You have to identify possible security weaknesses, throughout the system, the time of each incident that provides an insight into the total amount of labor that is used, and total time of each phase of the incident response process. And then only collect data that can be used to define and refine the incident handling process. And then you have to now perform an objective assessment of each incident. That's under the incident data collection. And you can see under the retention, some of the full determining factors for evidence retention is the prosecution. So when an attacker will be prosecuted because of a security incident, the evidence should be retained until after all legal actions has been completed. So you just have to retain that. And then the data type, an organization may specify that specific types of data should be kept, for a specific period of time. It all depends on the organization itself. And then the cost, if there's a lot of hardware and storage media, that needs to be stored for a long time, so it can be what become costly, as the case will be. So reporting requirements and information sharing. Governmental regulations should be consulted by the legal team to determine the organization responsibility for reporting the incident. Because this is also subject to the severity of the case. And the manual needs to determine what additional communication is necessary, with other stakeholders, such as customers, vendors, partners, and so on. The NIST will recommend that an organization, coordinate with organization to share details for the incident that occurred. just to help other organizations to harden their security architecture. So the critical recommendations from NIST for sharing information are as follows. These are the procedure. Plan incident coordination, with external parties before incidents occur. They also have to consult with the legal department before initiating any coordination effort. And they also have to perform incident information sharing, through the incident response lifecycle, which we have also discussed, and attempt to automate as much of the information sharing process as possible. And then they have to also balance the benefit for information sharing, with the drawbacks of sharing sensitive information. These are procedures before information sharing must occur with other organizations. So there's a lab for incident handling, which you have to apply the knowledge of security incident handling procedure to formulate that you do, and then you report. And so it's almost 6:30 already. So these are digital forensic and incident procedure. This module, of course, brings us to the end of the whole modules under the cybersecurity. But as you can see, this module gives you more legal background, legal knowledge on how to handle forensic data, and then peradventure an incident occur, the process of recovery or the process of response. What are the rules that are required? All that are stated in these modules to help us so that we don't do things blindly as cybersecurity professionals, because we are all coming from different backgrounds, some from engineering, from some science. So you wouldn't have more knowledge on legal procedures. But with this, it will go a long extent to properly guide you on what to do when an incident has happened and how to go about them. So at this point, I'm going to stop. If there are questions, then we'll discuss those questions. And if there are no questions, then we can, look at the next class, which is next week, Tuesday, for labs. And I'll just go on discuss most of these labs, just look at them together and before your exam. So any question? Hello, are we there, please? I hope I'm not monologuing.
We are there, yes.
Okay, fine. So if you have any question or concern, or can share that with us before some of us go for prayers.
Which lab we will do next week?
Yeah, the lab, as it were, you can do from 15 to should to provide that 15 to 20 should be provided now, and then from 20 to 28 will come latest the close of next weekend. And if that time is not enough, then you can do that submission before 17. So that will be in 17 will be 12 days time from now. So I expect to get all the labs from 15 to 20 between now and latest Tuesday.
So 17 will be the final exam.
Yeah, 17 will be the final exam. But like I said, those who are very curious, we have a lot of folks in this in this forum that are very curious to write the final exam. I'm giving them the opportunity.
But we have two exams.
Yes, we have two exams. We have the online exams, and then we have the lab exams.
They will be in the same day?
No, not the same day.
So the 17 will be the online or the lab exam?
The 17 will be 12 and 17 are considered to be the online exams. So you can choose to write it on 12 or you write it on 17. I'm giving that 1 week.
And what about the lab exam?
The lab exam will come on the 18th.
18.
Following day, yeah. So if you choose to write just on the 12th, 12th by my calendar is I don't know what yours is.
Thursday.
Thursday, thank you very much. That's 12. And then If you don't write it then you can write it on following week, Tuesday.
Can you give us also 2 days for the lab exam? Because I think in 18 I am so busy.
If you want 2 more days after 17, raise your hand up. You know, when you say if you give 3 more, everybody will raise their hand.
About
Some
the lab
folks are ready
exam
to write.
after 18. You said we will do the lab exam in 18.
Yeah, 18. Yeah, 18.
It will be only 1 day.
Yes, just 1 day.
Can you propose 2 days as the online exam?
No, I have 1 question to set. So I want everybody to be online to do the lab. I'm going to display that, and then I'm going to like display it on the screen, and everybody work on it and same thing.
Okay.
Doc, can you also share the packet tracer activities with us, because we only have the other labs but not the packet tracer labs?
Sorry, you said what?
I'm saying, can you please share the packet tracer labs with us as well, because we only have the other labs but we don't have the packet tracer labs?
I should share the packet tracer labs. Hello.
Yes,
I lost you.
the packet tracer activities.
Okay, you don't have them?
Yes, on the package that you sent us, there's no packet tracer activities.
Oh, really? Okay.
Yes.
Packet tracer activities are in the course online.
Yeah, in the curriculum online. If you already
in some models.
Okay.
So you come across that as you're going through. That's the reason why you have to read the online material. Hello.
Yes, we are hearing.
Okay, so let's go on. Let's get on with the activities. Like I said, 12th of October is the final, right? 12th and 17th. So you choose which of the dates for you. So I'm putting this on the group chat so that 12, 17 for online finals. But the practice exam will be enabled today. Okay.
Okay.
Yeah, and then labs, that's the skill-based exam. We said 18, 17, right?
About 18, I'm not okay for me.
Okay, let me just do
Because
this.
only 1 day between the
1 day will be
17
fine. Just
and
okay. Do we
18.
choose 18? Are we okay?
For the 12 and 17 for the online exam, I'm okay.
Okay, then let's just do the online exam on the 18th. I think I don't have a problem with 18th.
No, I said the online exam. I can do it in the 12 or the 17. It's okay. But the 18 for the lab exam, I don't know if all persons are okay or not.
Excuse me, is the lab exam, which is the skill lab NetAcad, which is not activated yet?
The skill based. I'm going to activate
skill lab.
I'm going to.
Yes,
No, the lab you're going to do. I'm going to set that lab myself and send to you.
not in NetAcad.
Yeah, not NetAcad. You will do that directly.
Yes.
It will be made available to you that day.
Okay.
I'll send it to you. You just do that and then send to me.
Okay. Thank you.
It will be in the PDF form, and I will send to everybody, either by email or in the course of the exam, because everybody have to come online, and then I'll share it on the screen and possibly send it across so you can all have it together. But please, you just have to be online that day to get it, and that's the reason why the lab exam will only hold once, not twice. Okay, so the skill based will be on the 18th. We all agree 18th. You agree on the 18th?
I think 18 is
Oh.
18 is fine by me. It's fine by me.
Or you want 19th? Okay. What is 19? 19 should be
19 will be better.
Huh?
It's better 19.
Yeah, are we okay with that?
Okay for me.
Fine as well. Fine.
Okay. Okay. So if we're good with this, that's okay. So I'm going to activate the practice final and the feedback immediately. And those of you that want to start working on that. So within the period, you can submit your labs. If you have questions or any issues, you can let me know in preparation for the finals. So thank you very much. Yep. So I can see so many people are very curious to just finish this. I believe we're all busy, so it will be made open. So the final exam is going to come in that succession. So you can do it on the 12th. You could do it on the 17th. So if you miss out on the 12th, and then for the folks in South Africa, I was asking them to let me know the schedule. I haven't gotten that up to now. So meaning that I guess you know what to do then. Either you comply with the 12th or the 17th. Okay, thank you very much.
Thank you.
Yeah, and have a lovely weekend.
Bye-bye.